All right, so this is lesson 1.1. We're towards the bottom of the page. The next up piece is the SO2 gas, sulfur dioxide, and it's at conditions that these are not STP. Remember, STP was 0 degrees Celsius and 1 atmosphere, which is, we can look at that later, but I guess for now we'll just make a note that this is not STP. Okay. So I'm going to draw the diagram. Here's an SO2, here's an SO2, here's an SO2. And let's look at the temperature first. Temperature at STP is 0, right? Temperature here is 30. That means hotter, obviously. What hotter means is that it has more energy, which means they're moving faster. So I'm going to look back over here. So the tails of my CO2 at 0 degrees Celsius are this long. I'm going to make these tails longer because it's hotter. Does that make sense? The hotter something is, that means it's got more energy, and that means it's moving faster. So hotter temperature. That sounds bad. Let's say higher temperature. Higher temperature, faster, longer tails. And then we'll talk about pressure. At STP, we're talking about 760 torrs. This has about half as much pressure as STP, approximately. So if you look back at CO2, there was 4 of them. Here, I only drew 3 of them. Less molecules would mean lower pressure. Okay, so let's write about pressure. About half the pressure. We'll say, technical term, less dense, or maybe a little easier, that means fewer molecules. I'm going to skip question 2 because I don't think that's going to be helpful for anyone right now. Remember last year on the second day of school, after I talked about question 2, I had to spend like 20 minutes explaining it. We're going to move on. It's not important. Number 3. So this is part 2, reviewing mole calculations. So this is your basic conversion stuff that we learned last year. And depending on what student we're talking about, you may remember it, you may need to review. So first question says, find the volume of 0.30 grams of CO2 gas at STP. So let's 0.30 grams of CO2. Volume at STP. This is one of those dimensional analysis things. Remember the conversions? So I like to put this over 1, and we have to convert it to moles. Quick review on converting from grams to moles. We have to use the molar mass. So the molar mass of CO2, we have 1 carbon, so 12.0. Let's use 12.01. And 2 times the oxygens. So oxygen is 16.00. Oh, that brings something up. I gave you the official AP periodic table on the front page.
Yeah.
That's the one you'll get on the exam, so you might want to use that one because its numbers are the specific numbers they use. So oxygen is 16, and there's 2 of them, which means 32. And so you add them together, and we get 44.01. And that's the number we're going to put up here, 44.01. We are wanting to know the volume at STP. And remember, at STP, 1 mole occupies 22.4 liters. So at STP, that's the relationship. So 1 mole, 22.4 liters. And this is something that we would put in our calculator. I already have it, so I'm just going to give it to you. 0.15 liters. And that's CO2. So I've got a note here, and we should write this down. Note, 22.4 liters only at STP. So our SO2 example that we just did, this wouldn't work. All right, so look at the second one. It says find the volume of 0.30 grams of SNO2 solid. And it gives us a density. So that's something that we'll need here in a minute. So the density gives us the relationship between grams and cubic centimeters. And the number we're given is 6.85 grams. And that's per 1 cubic centimeter. This is flipped. Grams is on bottom so that they cancel nicely. In this question, it asks for volume, right? Centimeters cubed is technically a volume. So at this point, you could probably just stop and be good with it. AP will be a little bit more specific, and they will say volume in liters. They'll tell you what they want. So this is a relationship that we use sometimes, a conversion between cubic centimeters and milliliters. This is not a difficult one to remember. It's the same. 1 cubic centimeter is 1 milliliter. And we want it to be in liters. 1 liter is 1,000 milliliters. Then it goes into the calculator, 4.4 times 10 to the minus fifth liters.